right, so I look on the next page and I didn't realize they essentially drew the exact same picture that I did, very, very close, where they're showing that F is below G, but they're both non-negative. So if you found that area, it would have to be positive, and it would have to be less than or equal to that. So what does that do for you? That's almost like a squeeze theorem. If you remember what the squeeze theorem was, we're almost bounding it by this upper bound of G. And in fact, that is one of the techniques that you'll possibly use in Calc 2. So theorem 5.8 says if f is integrable and non-negative on the closed interval, then the area beneath the curve has to be positive. As long as it's positive and integrable, meaning you can find the integral, which means it's continuous, right? When you integrate it, your area has to be positive. And then it says if f and g are integrable and f is less than g, then the integral of f, the area beneath the curve of f, has to be less than or equal to the area beneath the curve of g. And again, I can say area here, and the reason I can say area here is because we are assuming that they are non-negative.